Today, we're going to take a look at inventor assembly modeling. So assembly modeling is where you're taking and creating a complex object based on smaller objects. So for instance, if you have a car, think of a car, or even just the engine of it. You know, you can have your carburetor and your manifold and your spark plugs. All of those can be separate IPT files. And then you bring those together as one model, which you would call your assembly, much like you would assemble it in the real world, where you take this and put this to this and screw it together, and then that gets screwed into this, and this gets, so you get the idea. So what we're going to be looking at is that kind of concept. This is out of chapter 16, and you have to have access to drawings. Now if you follow in chapter 16, they want you to draw all of those pieces. Well, I've already done that for you, so we don't waste a lot of time, okay? So you need to go out to week 15, and you should find under there what's called the shaft support assembly drawings. There's 4 that you need to download. I would just put those out on your desktop. Base plate, bearing, cap, screw, and collar, okay? What I did is just downloaded them and then just dumped them over here on my desktop so that you'll have them accessible and you'll know where they are because we're going to be utilizing them, okay? If you do this on your own and you don't have access to that, what Inventor is going to want you to do is create them first in the book, okay? So an assembly is basically like an IPT. Okay, it's like a part, but it's a multiple part. So it has a different extension. So instead of an IPT, it has an IPA for its name. Okay, I think it's IPA. So what we're going to do is we're going to begin a new drawing file, but it's not going to be a drawing file. It's going to be, it's an IAM file, not an IP. Okay. So what we're going to do is start a new file, but this is called an assembly file. So we can go over to the new here. New. This guy should pop up. Notice there's your standard IPT. So those are your little parts. And all the drawings that I've provided for you are your IPTs. Those are your little part guys. We are going to generate what's called an assembly. You can see right here there's a 2D and a 3D component kind of assembly. We're going to grab this one called standard. Make sure you're English. Standard. And we're going to go ahead and create it. So technically, in the environment of where we're going to be working, it's going to look no different. Your model tree will still kind of have all the same things. Instead of calling it an IPT or part, it now calls it an assembly. Okay? But other than that, it should kind of look the same. Although you're going to have a little bit different tools here. You have this assemble tab that's popped up that wasn't there before. Okay? Is everybody good with that? All right, so we're going to create this. Now, one of the things that's kind of interesting to read that there are different methodologies that people use. And your author calls it top down and bottom up, kind of a concept of assembly. He calls a bottom up approach is where you go out and you generate all the little files first and then you piece them together, okay? What he refers to as a top down approach is where you can actually create more or less a tree structure of how the things are going to float together, but you don't have all the little parts in there because you may have different people working on the parts and you can bring it all together. In other words, you could also have like the engine done before you have other pieces of the car done kind of thing, okay? So that's for a more complex kind of thing. Guys that probably are designing cars or they're designing airplanes or those kind of things, okay? If we're doing a small project like we are, what they call a bottom-up approach is what we're using. So that's what we're going to be looking at. And that's what the book is going through, okay? So the first thing we have to do is we have to bring in one of these parts. So notice there is over here this area that called place. So we're going to grab this and we're going to do what's called place a component. Now, we have 4 components out there. Any one of those could be your base component. But it's really kind of, you want to think about, well, if I was building this, I would take this part first and then take this other part and then I would screw this into it. Okay, so the screw would not be your base component. Okay, it would be a secondary or ladder component. So we're going to use what makes the most sense. In our case, we're going to grab one that's called the base plate. So what I want you to do is where it goes to place, you need to go find this. So that's why I told you to put it out there on the desktop. So what I'm going to do is open up this guy. I'm going to navigate to the desktop. That's where I put my file. And then I'm looking for an IPT file. So down here, I'm looking for one that's called base plate IPT. So we're going to go ahead and select base plate IPT. Notice it should show up in the graphics. Okay. So again, that would be the part where you have to draw those first. Okay. What's that? Did you download it? Oh, you didn't. You just left them out there. They're out there in my documents. You didn't download them. Okay. So what I did here, just drag this here, drag this here, drag that there. And where's the base plate? I don't see it. Bearing, cap screw, collar. So this is the base plate. You're back in business, okay? All right, so once you see this guy, that's the right one that we want. We're going to hit open. So you may get this, that you're placing this component, you know, it's been saved, whatever. Just go ahead and hit OK. And then yes, so it'll bring it in. So this is kind of like in creating a block in AutoCAD and inserting it. It would be kind of analogous to that. Okay. The only difference is when you bring a block in AutoCAD, it now becomes part of that drawing file. And so you're actually inside that drawing file. So if I manipulate the other drawing outside, it doesn't manipulate the model inside. In this case, they're linked. So if we open up the base plate file, it'll update the one that's in the assembly file. Okay, so there's a big difference, but they're similar. Okay, you get the idea? So notice this thing is free to float, right? Wherever. So what we're going to do is we're going to place this thing locked down. Okay, so you're going to right click on this and you want to place this thing grounded at origin. So you don't have to do that, but what this does is just locks it into a location, okay, right where your origin is. And you can still continue to place parts, so we don't want to place any more parts, so we're going to right click and then we're going to say okay. So we just have that one part there now. Okay. This thing is fixed. It has what's called no degrees of freedom. So you can't move it left, right, up, down, or you can't rotate it because it's locked down. Okay? And again, you don't have to do that, but that's a really, really good thing to do. So we're going to place another component. Now, by the way, let's look at the tree over here. If you notice now, you have your base plate shows up. And under your base plate, you'll notice you have origin settings and sketches and all of that. Okay, so all that stuff is there available, all right, under our tree. You guys all good? So we're going to do another placement. This time we're going to go out and place what's called the bearing, okay? So we're going to open the placement again, navigate to the desktop. That's where I put my files. We should be looking for one that's called the bearing. It should look like that, kind of a gold color. It's got 2 tabs with holes in it for screws. We're going to go ahead and open this up. Just accept the defaults there. Notice now this guy's free to float wherever. Don't worry about where he goes. Just kind of put him near that part right there. And then go ahead and right click and say OK. All right. So we should have that. And notice over in your tree, you now have the bearing. Okay, so you have 2 parts there. One is the grounded base part, and the other one's kind of free to float. What? Bring it in. Okay. So notice this guy's just floating in space, and I'll tell you this, by the way, when you are looking at this in 3D space, you don't always know where this thing is, because it can be really, it doesn't even look like it's above it, but it can be, or it can be right in the middle of it. Right now, we don't really care, but we are going to lock these two guys together, okay, in a minute. All right, how's that looking for everybody? Is that all good? And notice, again, you have your base plate, and notice there's a little symbol where it says base plate. It's got a little stick pin sitting in that. Do you see that? If you look at the name, it looks like there's a little pin right there stuck in it. That tells you it's grounded, okay, so it's locked. But the other one doesn't have that, so it's free to float. Okay, we good? So we're going to look at what we call degrees of freedom. So I want to show you this, and there's a little symbol that we're going to turn on because this is awesome, because this tells you what degrees of freedom each part has. So we're going to navigate over to the View tab, the top, View, and notice there is one that's called Degrees of Freedom right here under the Visibility section. All you're going to do is turn that on, and you get a little symbol that is now popped up in your part here, your bearing, and it shows you the degrees of freedom that this thing has. So, can anybody tell me how many degrees of freedom this thing has, based on this symbol, that symbol? There are 6 degrees of freedom. So notice you can move it up, down, in an X direction, in a Y direction, and then you can rotate about each axis. So you have 3 translations, the moves, up, down, left, right, and then you also have rotations. Rotation about the X, rotation about the Y, and rotation about the Z. Once we start to bring these parts together, we're going to lose degrees of freedom. In fact, you always typically pin it down so you have no degrees of freedom or maybe just one left. Okay, so it just depends on what your model needs to do. Okay, what do you notice about the base plate? How many degrees of freedom does it have? Zippo, it's locked. Okay, so it can't move left, right, up, down, side to side, nor can it rotate. Okay, is everybody good with that? All right, so we're going to go back to the Assembly tab, and we're going to talk about constraints. So constraints, this is the big deal when you do an assembly, is how do I bring this part coincident with this part? That's called a constraint. And that can be a little hairy once you do it the first time. After you start doing it, it's pretty simple. But there's several different types of constraints we're going to talk about here. So if we go to this constraint tool here, notice it pops that out. And there's your constraint types. This guy right here, which is called a mate constraint. So I can bring 2 pieces, 2 surfaces together, like that. Now, I can not only bring them together, but I can have an offset. So they can be together, but there'll always be an offset. So the one can ride above the other one always, but it's always at a fixed distance. So they can either physically touch or not touch, but if the one moves, if the parent moves, the child's going to move with it the same way, okay? You guys get the idea? Then we have what's called an angle constraint. So you can maintain an angle setting between them. You can have a tangent constraint. Then the one you use a lot when you have screws and those kind of things, these guys right here, this is called an insert constraint. Okay, so I use that one a lot. And then this one is a symmetry constraint. Okay, so in your book, it goes into a little bit more depth about different types, because when you get in, for instance, when you get into the mate type constraint, there's 2 solutions. What they call mate, which is surface to surface, or flush, which they go the same direction. Okay, so they're mating, but they can mate differently. Okay, so we're going to kind of see how all that works. Okay, and it's not really tough, but you got to go through it a couple times. And quite frankly, I'm going to show you, if you make a mistake with constraints, you can do undos, but I found it's a lot better to delete the constraint. Okay, So I'll show you what I mean by that, because we may have some people that are going to have some issues today, okay? All right, so the first thing we're going to do is we're going to bring this guy base coincident with this guy's top surface, okay? So what we're going to do is I'm going to just cancel this command so that we're not doing anything in it, and I'm going to go ahead and get back into it. Make sure you are set to what's called a mate constraint. And the solution type we're going to use is this one called mate, okay? So we're doing a mate constraint with a mate type solution. We're going to choose the top surface of the base plate, this guy. Make sure you see that little green arrow pop up like that. See that? Anywhere on this surface, it doesn't matter. But just when you get it, just left click it. So now it wants to know the second object. So what I want to do is I want it to be coincident with the bottom of this. So what I'm going to do is rotate my view, and then I'm going to click the bottom of that, and it automatically just jumped right over to it like that. Okay, did that work for everybody? You then want to go ahead and apply that constraint. All right. Now what you notice, do you notice you've lost degrees of freedom there? So notice I can move this thing left, right, and I can rotate it, but I can't raise it. Now it looks like I'm raising it, doesn't it? If you look at this guy on an edge, you'll notice it can't go up, but it can go left, right. Okay, so it actually, depending on your view, okay, that can make a huge difference. Okay, does everybody see that? All right. So did everybody get that to work? So what we're going to now do is constrain the hole in the one part with the hole in the other. We're going to line them up. And we're going to use a mate to do this. Now, there's a couple of different ways you could do this, but find yourself, I just want to go through this as a different way. So we're going to apply a second mate constraint. You might want to get yourself in an isometric view. So if you hit F6, you could get into a view like mine is right there, and that should put you in an isometric, okay? This guy should still be open right here, so we're going to apply another mate constraint. The book, and I'm going to tell you what, the book tells you to use what's called a flush one, and I found flush doesn't work. So I'm going to try this. We're going to try this and see, and if it doesn't work, we may have to redo this. But what I want you to do is we're going to select the counter bore on this guy right here. So we're going to select this guy under a mate. Let's see. It's not letting me do it. I think I already select, for some reason, that looks like it's already selected. Let's go ahead and just go ahead and hit cancel here. All right. We're going to get back into this tool. Okay. I want you to go ahead and open up bearing, and you should see that you should have a mate showing up there constraint. Is that good for everybody? We ready? Okay. So we're gonna do another mate constraint. Like I said, sometimes this doesn't want to work, right? So what we're gonna do is go ahead, go back into the constraint. We're gonna do a mate. This guy. I want you to come over to this hole and touch that till you get that axis that comes through it like that. Okay, so you want that axis to show up like that. And then I'm going to come down to this hole and do the other axis. It should bring them together like that. And if that looks good, go ahead and apply it. And then you can cancel this out. So you now have applied 2 constraints to this. How many degrees of freedom does this part have now? No, it's got 1. You see? So this thing is what? Locked to that hole and it can spin. So if you actually take this guy now, notice it'll spin around that hole, but it won't move any other way. You see that? If yours is not doing that, you don't have that constrained correctly. Okay? And again, if you look at it from different points of view, you can see what's going on with that. Okay? It's top down. Notice it can rotate. If I'm truly top down, you should notice that your holes are lining up perfectly. So if there's something off center there, then that could be a problem as well. Is that working for everybody? Now, what I said before is that if you have a mistake in one of your constraints, what I've found out the best way to do is right-click on the constraint and then you can delete it. Okay? Rather than trying to do an undo, I would say right-click and delete it. Okay? So we're going to bring these guys coincident. There's a couple of ways to do that, but we basically want to swing this hole over till it matches with that hole. So we're going to do this with what's called a flush type of mate, okay? A flush one. So in order to do this, this is pretty cool. We're going to turn on planes to be able to see this. So what I want you to do is we're going to go out and create some visibilities. So I want you to go to the base plate, open up the base plate, open up the origin folder. And what we're looking for is the XY plane. So if you click on the XY plane, right click on that, make it visible. You should notice that that's coming right through the middle of my part. There's my plane. Everybody see that? And so what we're going to also do now is we're going to go to the bearing, the origin folder. We're going to grab his XY plane and make him visible. What you should see is when you look at the, whoops, I think I made the axis, I made the wrong thing visible. Hold on. I should have done my XY plane. XY plane visible. So you should notice that you have the XY plane of the base part and the XY plane of the bearing part. So what we're going to do is we're going to snap these guys coincident. We're going to bring the one plane coincident with the other. So it is going to swing that the angle it needs. And we're going to do a mate to do this, but we're going to apply what's called a flush constraint. Okay? So with those guys visible, just get them kind of so you can see kind of both of them like that. And we're going to go into constraints. We're going to do a mate type constraint, but we're going to set this to flush. Okay? We're going to set it to flush. And then we're going to select the plane of the base plate. And then we're going to select the plane of the bearing. Should snap them shut like that. And if you notice, they should be perfectly lined up now. The holes line up. Everything should be good. Okay? And it's kind of different if you go into a mate option. Notice what will happen. Usually it rotates. They're still aligned, but they're not aligned in the flush direction. So, I mean, that may be what you want, but in this case, we want it to be flush. So after you get it to look like this, if that's good, go ahead and apply it. And then you can close this. And so now you should see what we've got. If you're looking top down, notice you're straight on where you need to be. Those holes are lining up. Everything's good. All right, is that good for everybody? So we're going to now bring in the collar that's going to sit on top of this guy. What I'm going to do is turn the visibility off on these planes because I don't really need that right now. So I'm going to go into this plane, turn off his visibility, go into this plane, turn off his visibility. And I'm going to collapse these folders because I don't necessarily need to see all of that stuff. Sometimes it's nice to see it. Sometimes it's not. Okay. So we're going to place another part. Now notice that this is really cool. Notice any degrees of freedom on that other part now. We have no degrees of freedom on both of those, right? Everybody see that? That disappeared. This guy is completely locked down. So that bearing is actually a child of the base plate now, the way it's linked, okay? All right, so we're going to go to place, and we're going to, again, navigate to where we've got our models, go to the desktop. I'm going to open up, let's see, I want to find one that's called a collar. So it's basically a cylinder with some holes down through it. We're going to go ahead and open up that collar. Again, just accept the defaults there. And notice this guy comes in, place him anywhere, just kind of out of the way. When you're done, go ahead and right click and hit OK because we only want one instance of that. And this guy is got multiple degrees of freedom. He's got 6. He can rotate about X, Y, and Z, and he can move in an X, Y, and a Z direction. Okay. Is that good for everybody? So when you have cylinders that line up, things like screws into holes and those kind of things, one of the best ways to do it is what they call that tangent one. Okay. Or not the tangent, I'm sorry, not the tangent one. It's the one that's this one. It's called an insert. So we're going to generate what's called an insert on this one. And I'm going to select insert. And the solution type I'm going to use here is what's called opposed. And what I'm going to do is I want to make sure I'm snapping the right surface. So I'm going to come down here. Make sure you get either that arc there. Whoops, don't get the bigger one. I want that smaller one right there. Either that circle, or there might be another circle there. Either one of those would be valid. I'm going to use that inside circle. Make sure you're getting that guy to shoot up. So I'm going to go ahead and hit left click that. And we got to find basically the same point in the bottom. So we want to rotate until go to the inside like that. That should have brought that guy over. And notice it locked down its degrees of freedom. So we only have 1 degree of freedom now, and this thing's free to spin, which is okay. So I'm going to go ahead and apply this, and then I'm going to close it. So now as we look at the collar, he's there. You can actually pick on this thing, and it's hard to see that it's rotating, but I can rotate that thing around because he still has 1 degree of freedom. And also remember, he is now a child off of that off of the bearing, and the bearing is a child off of the base plate. You see now this is working? It's pretty cool. Also, notice after you brought in base plate, it says 1. There's 1 instant of that, okay? And then bearing is 1, collar is 1. Also, it's kind of neat. If you pick over here on the name, it'll highlight the part that you're talking about. So if I come over here and hit bearing, it highlights my bearing. There's my base plate. There's my collar. All right, so we're almost done. What we're going to now do is place 2 screws. So we've got a screw here and a screw here in that counter bore. So what we're going to do is go out to place. We are going to find from the desktop, I've got one there called cap screw. Cap screw. So it looks like that. Go ahead and open that. Accept the defaults. I'm going to bring my cap screw. I'm going to have 2. So I'm going to bring 1 here and 1 over here. And when I'm done, I'm going to hit right click and OK. So again, as you navigate out, you should see there's 2 screws. Over here, notice now there's cap screw 1, cap screw 2. So it's actually keeping track of the number, and each instance of that insertion, it has its own point on the model tree. Okay? So who can tell me, based on what we just did, what's a good method of aligning that screw up into that hole? What do you think we could use? Under the constraints, what do we use?
The bottom of the head to the invention into the hole.
Yep, and I'm using this guy called insert, right? Okay, so I'm going to use that one, and I'm going to go here, and I'm going to select this guy down here at the bottom of the counter bore on the inside, and I'm going to come up here, and I'm going to do the same thing, the bottom of the screw right there. And notice that looks like it did what it wanted me, what I wanted it to do. And if I hit apply, it took it in. And it only has 1 degree of freedom, which means it can spin. Okay? Just let's see. Did you? Oh, don't select that. Go ahead and cancel. Try to. Let's try this. Let's do that one. Yeah, now zoom up in here so we can see it. Why don't you just use the wheel? Your mouse. There you go. Now we're going to pick the bottom. This guy here. Zoom up a little so you can see it. Just use your insert constraint. Now pick this thing right here. There you go. All right, now zoom out so you can see the other one. You just need to learn how to use your mouse. So you'll see. Then we're going to do this. So I'm going to come up here so I can see the bottom of this part right here. Okay. Well, that worked, but yours isn't linked down to that. So that's what it should look like, but you don't have the other part. So I'm going to go ahead and apply that one. This part needs to be submitted down to that, but we can use the same technique. Did you get the idea? Okay. Everybody else all right? Okay, did you get your other screw set? Go ahead and do the other screw. So I'm going to, again, use the same insert. Make sure I get the right part on that pole because it's going to line them up and also make them flush at those same surfaces. So you got to play with this a little bit. Trust me with these until you really get the hang of it. So once that goes in, notice there that is. If you like what you see, apply it. Go ahead and cancel it. You should notice what you have there. You have your two screws. They should be countersunk down into that. And that's what they should be looking like. Okay. Any questions on that? Are these screws free to move? Well, notice that you can take that thing and you can drag it around. Notice I can turn it because it has a degree of freedom in that direction, but everything else is locked down. Okay. What's that? I'm sorry. No, you can't. I mean, you can go either way, but it's not going to move. It's not going to work like a screw because it doesn't have threads. Okay. So it knows nothing about threads. And it can only turn because it's locked. It can't go left, right. It can't go up, down. It can't go forward, backwards, okay? But it can turn. And also the other degrees of freedom. So it actually still has 1 degree of freedom. You guys seen how that works now? So if you do like an F6, you should see you've got your part very nicely in place. We could look around this. You might want to look around this and make sure everything looks good. Look underneath. You can see the screws are coming right where they need to be. They're not too high. They're not too low. You know, so you always got to check that kind of stuff out when you're looking at these models because it's really easy to get things wrong. Okay. But that's what we're looking at. So I'm going to go ahead and do an F6 and put it in a nice isometric. Also notice if you open up, for instance, the cap screw 2, that was an insert type thing. If you wanted to change that, like I said, sometimes the best thing to do is to delete it and then do it again. Okay, so it really don't try to do undos. Okay, with these, I would try to do that. But each one of those has their mate conditions and you know what you did with that, the constraints that are associated with it. So it's actually pretty cool the way that's working. Okay, is everybody good on this so far? It's actually the biggest deal with this, guys, is dealing with the constraints, getting them right, okay? And if they don't look right, then they're probably not right. And like I said, then I would delete them and go through it, okay? So we're going to make a change to the model. So let's say that somebody wanted to change the hole size of that model. So what we can do is we can go to our IPT file. I'm going to open up the IPT file for the, let's see, I want the bearing. Go ahead and open up your bearing IPT file. Okay, so notice this is the drawing, or this is the model that is driving the assembly. So if something changes in here, it's going to change in here, which is kind of neat. So let's go to the bearing IPT file. And we're going to look at one of these, that hole extrusion right there. I think that's okay, that's that extrusion 3. Go ahead and double click the sketch. And you'll notice if we wanted to change something like the size of the hole. So the diameter right now is set to 0.375. So if I said, okay, I wanted to change that, you could double click that and make that 0.25. Go ahead and okay that. Finish the sketch. It altered the hole here. And if we go back to the assembly, that hole there is also now altered. Can't really tell much difference, but that hole is being driven by that model. That model changed, and so the assembly changed as well. All right. So that's also pretty cool because those guys are linked, right? And now that also means that if you have an IPT file that's not in your location of where your assembly can find it, you can have problems too when you open your assembly. Okay, so they do have to have that link. Okay, is that good? Is everybody good? All right. So that's kind of cool the way that all works. Now we're not gonna. The author goes through a process, and you guys can do this on your own, where he adds another block within here. So instead of going out and creating a separate IPT file, you basically creates one inside the assembly. You can do that as well. We're not going to worry about that because we don't need to know how to do that. That's for sure. I do want to show you though how to create a drawing file out of this. Okay, now that we have this assembly. So go ahead, we're going to put it in an isometric mode just so that we agree we got this thing the way we want him. So what we're going to do is let's go ahead and save this assembly. So I'm going to do a save, and I'm going to save this to the desktop. And it's going to call it assembly 1. You can call it whatever you want. I think this thing's actually called a shaft support or something like that. So if you want to call it, let me see what he calls it. Calls it that. It's called a shaft support. So if you want to call it shaft support assembly, that's what I'm going to go ahead and call it. Shaft support, and save that. Okay. The reason we want to do that, first off, of course, is something crashed. While you're getting into this mode, you don't want to have to go back and reconstruct it. And sometimes an inventor, if you don't do certain saves, it's going to require you to before something happens. Okay. Everybody okay? So we're going to create a drawing file, just like we did before, but we're going to add a few things. So I'm going to show you how to do part list, and I'm going to show you how to do balloons. Okay. So we're going to go into a new drawing file. Actually, I want to do new over here because I want to make sure that I'm getting, when I do the new, I want to make sure that I'm getting an English new, okay? So make sure that you're under English, ANSI. Go ahead and create that. And there we have it, okay? You should have a sheet there. Is that good? Does anybody have windows that are open? Are they open? You can just right click on them and delete them if you want to. Okay. So I don't have any. For some reason, mine's not showing them up. If it is bringing those in, just delete them. We're going to bring in our own. Okay. Did you get it to work? Okay. All right. Everybody good? All right. So we're going to go ahead and we're going to place a base drawing. So we're going to go base. And we're going to bring this in like we have been bringing it in. I'm going to go ahead and take it to an isometric. So if you click the corner on that, that'll be good. I'm going to kind of just, let's say, let's do the view. Oh, we can do the view at 1:1. That sounds good. Go ahead and place that. And when it comes in, it should look like that. And I'm going to go ahead and just kind of move this out of the way like that. So you'll notice there's your picture. Everything's nice and in there, but the sheet size is probably a little big. Mine came in as a D size. Everybody come in as a D size. So what we're going to do is we're going to change the sheet size up. We're just going to right click on sheet number 1, edit the sheet, change that from a D size to a B size. Everything's good. We may have to reposition our part, which is what I'm going to do. I'm just going to kind of bring these guys over here, kind of in that corner. And that all looks good. Okay. There are, by the way, different shade modes on this. If you click in here and right click, you can go to edit the view within this. And we've talked about this quite a bit before, but you've got scale factor settings that you can change. You can turn on your hidden lines. So if I turn on hidden lines, notice I get hidden lines in there. If I don't want to see hidden lines, turn them off. I could also show that as a shaded model. So I could have a shaded model. So you've got different views that you can do on these guys. So what we want to make sure that we are set to is not shaded. We don't want it shaded, and we want just hidden lines. So it should look like, well, I don't want the hidden lines. I want to remove them. Sometimes if you have hidden lines on an isometric, it's too much. It's way too much, okay? All right, is that good? So we're going to create now what's called a parts list. This is pretty neat. This is just, it's so automated. It's just amazing how this all works. So we're going to go to the Annotate tab. And there's two areas we're going to take a look at today that are new. One is this guy called Balloon, and the other one is this guy called a parts list. So what we're going to do is go generate a parts list first. Parts list. This diagram pops up. Okay. What the first thing we're going to need to do in the parts list is select the view. So go ahead and select view, select the base view so it knows what model it's dealing with. Okay. There are different types of bill of material views. You have what's called structured, you have parts only. Okay, we're just going to use what's called structured. Going to hit OK. And it'll tell you that this thing has been disabled. Go ahead and hit OK to that menu. And what we're going to do is bring this guy down. We're just going to kind of put it to the side like that. And following command, if that pops up, just hit OK. So what you'll notice now, here's our parts list for this piece. So it shows you the item number, 1, 2, 3, 4, the quantity of each, which, look at that, it's pretty cool. It tells me how many screws. It knows how many screws I put in there, right? That's pretty cool. It tells me the number of screws, the number or quantity of each part. There is no description on this. And we actually have materials, but the materials aren't showing up. So what we're going to do is we're going to edit that. So we're going to right click inside of this. And let's see, we are going to, I think it's edit the parts list. We're going to right click and go to edit the parts list. So this box pops up. So you can change some things in here, but what we want to do is add a few things. So we are going to go to what's called the column chooser. That's this guy right here. That's your column chooser. Okay. Select that little guy right there. What this column chooser is showing me is right now, the selected properties that it's showing me is the item, the quantity, the part number, and the description. We don't care about the description, so what I want you to do is click on the word description and then remove it. Okay, so that'll take it out. Now what we're going to do then is find the material, and then add it, and then hit OK, and apply that, and then OK it. What that did was I added that material, and since I had materials on my model already, those showed up. Now, this thing needs to be moved around a little bit, so what I'm going to do is I'm going to move this guy up. These guys are a little bit hard to move around. And I need to open this up a little bit like that. So I'm going to increase the size of that. You can just drag that around pretty nicely. But there's my information. And you can do things like get rid of the word parts list or add some of that stuff in there. But all of this is linked to that model. If that model changes, this changes. It is so cool. If I went back to my IPT file and changed any of the information in the IPT file, it's automatically going to update in this drawing. I mean, automatically. That's simple. Okay. Any questions anybody has? Notice on mine, this nickel copper Ally 400 is too big to fit in that. So if I drag this guy over, I can make that so that's all on one line. So you can drag those columns around a little bit, make them smaller. So I don't really need quantity to be that big. And I don't necessarily need item to be that big. So I can drag those around if I want to. Okay. So you can format that thing any way you want. So let's go ahead and do a save. Oops, yeah. Okay, so we're going to do one more thing here. We're going to bring in balloons. These are really neat. So these balloons are just going to show you part numbers. So I just click on balloon, click on a part right here, pull it up, click, and then right click, hit continue. And notice it knows exactly what that part is I touched. If I come down here, continue. Oh, and if they don't place right, you can move them around after the fact. So I got one I need to move. There's my screw. I'm going to bring that out, right click, continue. And I got one here I'm going to bring out this way. Okay, so those are correlating with the item number. I mean, everything's just keeping it, it's all cool. Now notice this one, this one didn't work right for me, so I just have to drag him out. Those things can be dragged really easy anywhere. What's really neat, watch this. Notice this one is touching the screw, but if I move that so it touches that part, it changes the number. It knows exactly what it's touching. So it's, I think the tools are so easy to use in Inventor, it's unreal. Okay, they're so easy to use. You guys getting that to work? So you got your parts list, you got your balloons. We're going to be doing this on that little drawing that I'm going to have you guys do. So we're going to be doing that exact same thing. Right? You guys getting this to work? Isn't that pretty amazing? I mean, it's just pretty incredible. And actually, if you have moving parts, like say a piston and a cylinder kind of stuff, you can actually animate this. So you can't animate an assembly drawing, but there's another type of drawing they have that'll allow you to animate it, and then it's just incredible. And then you can actually generate the animation for somebody presentation-wise. Okay. All right. Any questions? Let me ask you this: if I wanted to bring in a different view on this model, could I do this, or could I just maybe bring in one of the IPTs? Does anybody know? Could I do that on this drawing? So let's say I wanted to open up one of these other IPTs and bring it over here and add a dimension in. Okay, well, the answer is yes, I can do that. What I would do is I go over to Place View, I go to Base, and I find the drawing that I want to play the base on. So for instance, I would have to open this up and go to where my part is. So I have a bearing right there. Bring that guy in. I could bring that part right there. And then I could bring a projected view on the top and then create those two views. Those guys can be brought in separately. Okay. And then those could also then be annotated with dimensions and those kind of things. So on a small drawing, this wouldn't make that much sense, but in this one, it's not bad. Okay, you guys get the idea? So if you have time, you might want to go through chapter 16 on your own. You don't have to draw all the parts. I already did that for you, but you should be able to follow through the steps. We're going to be doing that on that 13th assignment, okay? Which is our last assignment, by the way. So this will be the last thing. Okay. Any questions? Okay. Well, I'm going to stop the recording then, and I'm going to go over